Good day, everyone. I am Carl Dashel R. Del Valle from Grade 12 Watt, and for today's discussion, we are going to talk about current, resistivity, and resistance. So to start with, let us all define muna kung ano nga ba ang current. So current typically refers to the flow of electricity through a conductor like a wire. Siya ay measured in units called amperes. So, if your current is higher, it means more electricity is flowing through the wire. Para naman sa ating formula, we have I, which represents the current in amperes, Q, which represents the charge in coulombs, and T, which represents the time in seconds. So our formula expresses current as the rate of flow of electric charge over time. So if you know how much charge passes through a point in a certain amount of time, you can calculate the current using our formula. Now, let's take a look at this example. An electric vehicle needs to be charged with 7,200 coulombs of charge to complete a trip. If we have 2 hours to charge it, what current is required? So ang hinahanap natin sa problem na ito ay kung ano nga ba yung current. So, I ang ating hinahanap. For our given, we have a charge of 7,200 coulombs and we have a time of 2 hours. As mentioned earlier, we said that time is measured in seconds. So, based dun sa ating given problem, nakita naman natin na 2 hours yung naka-indicate. Kaya ang kailangan natin gawin in order for us to calculate the current ay need muna nating i-convert yung 2 hours into seconds. Paano nga ba natin siya ginagawa? Alam naman natin na ang 60 minutes ay equal sa isang oras at ang 60 seconds ay equal sa isang minuto. So 2 hours times 60 minutes all over 1 hour times 60 seconds all over 1 minute is equals to 7,200 seconds. At ngayong nakuha na natin yung time in seconds, pwede na natin siyang isubstitute sa ating formula. Again, for our formula, we have I is equals to Q all over T. We have a Q of 7,200 coulombs and time, which is 7,200 seconds. Dividing these two, we will have 1 ampere. Next, we have current density. By definition, it is like a measure of how much electric current flows through a given area. For our formula, we have current density, which is represented by J, equal to I, which is our current, all over A, which is the cross-sectional area. So, it's like looking at how much current is flowing through a particular amount of space within a conductor. Let's take a look at this example. A copper wire carries a current of 3 amperes and has a cross-sectional area of 0.5 square millimeters. What is the current density in the wire? We all know that the given is 3 amperes, which is our current, and our area of 0.5 square millimeters. However, based on our given, our area is not measured in square meters. It is measured in square millimeters. With that, we need to convert our area from square millimeters to square meters. Para magawa natin yon, we need 0.5 millimeters squared times 1 m squared all over 1,000 millimeters squared. And with that, we have an area of 5 times 10 raised to negative 7 meters squared. Now that we have our area measured in meters squared, we can now substitute our given to our formula, which is J is equals to I all over A. So I, we have 3 amperes, and our area, 5 times 10 raised to negative 7 meters squared. So dividing these two, we will have a current density of 6 times 10 raised to 6 area per meter squared. Finally, we have resistance and resistivity. So ano nga ba yung pinagkaiba ng dalawa? Resistance refers to how much a material resists the flow of electricity. It's like the opposition electricity faces when it moves through something. On the other hand, resistivity is a property of the material itself. It tells us how strongly a material opposes the flow of electricity. For the formula of resistance, we are going to use the Ohm's law, which is I is equals to V times R. Manipulating the formula, we will have R is equals to V all over I, wherein V is the voltage and I is the current. For the resistivity, if there is a given length and area, we can have R, which is resistance, is equals to resistivity times L, which is the length, all over A, which is our area. Applying this concept to our sample problem, so you have a copper wire that is 2 meters long and has a cross-sectional area of 1 times 10 raised to negative 6 meters squared. The resistivity of copper is 1.68 times 10 raised to negative 8 ohm per meter. What is the resistance of this wire? We have our given length of 2 meters long and a cross-sectional area of 1 times 10 raised to negative 6 meters squared. We also have our resistivity, which is 1.68 times 10 raised to negative 8 ohms per meter. Again, since there is a given length, area, and resistivity, we are going to use the formula R is equals to resistivity times length all over A. Using direct substitution, we will have R is equals to 1.68 times 10 raised to negative 8 times 2 all over 1 times 10 raised to negative 6, which equals to 3.36 times 10 raised to negative 2 ohms. Therefore, we have our resistance 3.36 times 10 raised to negative 2 ohms. So that's it for our Matuto series for today. I hope you learned something in this discussion.